Okay, what we're showing here is a deep cycle battery, and you should probably hear a background noise. Well, that noise is coming from the battery. Now, I am going to walk up to the battery, and I'm going to show you some actuators inside the battery. By the way, the battery's empty. But if you look at the battery, there's 3 actuators inside that battery. Those are Mayday patch actuators. And the frequency that you're at right now is something that you can hear. But I'll put the top back on and we can continue to listen. This is a very simple frequency generator. And I'll go down in frequency and you can listen. That has come from the battery. So right now we are at approximately 300 hertz. We'll go up into the range in the kilohertz. We're at about 2.75 kilohertz, and that's coming from that battery. You can see that in the design that I am proposing, those patch actuators will be in the sleeves within the battery case, and all the wires and everything will be within the mold, so it will not affect the manufacturing process whatsoever. And the actuators that we design will be of the frequency that we need to get the beneficial performance. So that is sound. You can hear that. These actuators are actually very good around this range. They get much better around the 30 kilohertz range, because that's how they are designed. AGT actuators will be designed with actuators that are resonant in the 6 megahertz range. But the same principles hold. So now the sound is outside of our hearing spectrum, because we are approximately 15 kilohertz. I don't think you can hear that. If you are a dog, you can hear that. But you're not a dog. So you shouldn't be able to hear that. So we'll go back down to 20 kilohertz. And we should not be able to hear that. But if we go to this is range B. So we're at 600 hertz. You can hear that from the battery. 700 hertz. 800 hertz. 1000 hertz. 1500 hertz. 2000 hertz. And then we will switch to C-band and go back down to 2000 hertz. Four kilohertz, 6 kilohertz. Now listen as I open the top of this battery. The noise will get louder because the amplification of the sound is happening at that sleeve within the electrode, at that sleeve, and at that sleeve. So of course that when you put the top back on, you will muffle it. But the point being with AGT is we want to have signals in the megahertz region within inside the battery. 8 kilohertz, 9 kilohertz, 10 kilohertz. Out of our hearing drift, 15, 20. So now a bunch of dogs hear it. So the thing that we need to do with AGT is we need to design actuators that do the exact same thing and that are efficient in the 6.5 megahertz region, which is very easy to do. But the idea here is to do it with the actual case. And here's an empty case. The electronics can fit up in that area right there on the top. And there is the actuators. And in my embodiment, as we talked about, there will be a way to slip the actuators that are resonant around 6.5 megahertz actually into the interior of the battery. Thanks. Bye. Ugh.